Okay, guys, next question, number 4. We are looking at 2 traits now. Dihybrid cross. Di meaning, prefix meaning 2. So 2 traits. So in the book, we're looking at 2 traits. We're looking at eye color, and we are looking at earlobes. So, eye color. We have 2 possibilities in this example. Dark eye color and blue eye color. Dark is dominant to blue. In earlobes, your earlobes can either be attached like this, kind of like that to the side of your head, or free like mine are. Free is dominant to attached. So, the question wants us to take a parent who is homozygous dominant, remember homozygous means the same, homozygous dominant for both of those genes, and cross it with a parent that is homozygous recessive for both of those genes. So here's what that looks like. I've used E to represent eyes and L to represent lobes, okay? So we have our homozygous dominant parent over here. They're homozygous for the eye gene and homozygous for the lobe gene, and they're dominant, both of them. Opposite over here, this individual is recessive for both genes. So they have 2 genes for blue eyes, 2 genes for attached earlobes. This guy's got 2 genes for dark eyes, 2 genes for free earlobes. So if these guys were to have a baby, they've got to make their gametes or their sex cells first. And if you remember, we take 1 copy of each gene for the kid, right? So we get half of our genes from mom, half of our genes from dad. So if each parent makes those gametes, this is what it's going to look like. Because this parent can only give a big E and they can only give a big L. This person can only give a little E and a little L. Okay? If you remember our math from before, one times 1 is 1. So when these guys mate and they have a baby, there's only one thing that the baby can be. Which is this. So we get 1 E from one parent, 1 E from the other parent. We get 1 L from one parent, 1 L from the other parent. So this is what this kid looks like. This kid is heterozygous for both traits. This individual still has dark hair, still has free earlobes, but they're heterozygous. Hopefully you're following with me so far. Now, the thing about a dihybrid cross is we take 2 of these guys and cross them with each other. So we take 2 of these guys and cross them with each other, and this is where it gets kind of complicated. Because we know that each parent has, a big E and a little e, a big L, little L. Going back to our math, this parent has 2 different options it can give the baby for E. They have 2 different options they can give the baby for L. Same with this one. So if we do our math, each parent has 4 different options it can pass on to the kid. And that's what makes this complicated. For these guys, these are our 4 choices for each parent. This parent can pass on, remember, all these have the equal likelihood of being passed on. Equal likelihood. So we've got a big E, big L, little e, little l, or big E, little l, little e, big L. And these four are the same for the other parent because their genotypes are the same. So we've got these four over here for this parent and the same four over here for this parent. So we got to figure out exactly what any of their possible babies are going to look like. And this is where we have to draw a big Punnett square. We are charting possibilities here. The writing backwards thing again. Can't do it. Can't do it. I feel like I'm doing a pretty good job, all things considered. This is what we get. It is a 4x4 Punnett square. Now, looking at this, it looks daunting. It's really okay. Same principle as before. You take what's on the side, match it up with what's on the top. So we've got a big E, and a big L, big L. Same with this one. Big E, little e, big L, little l. And you just fill out this whole thing. Now, I'm going to tell you that if you were to fill this all out and look at the different genotypes, this would be the spread. We'd have 9 to 3 to 3 to 1 ratio of genotypes in this Punnett square. We'd have 9 of one, 3 of another, 3 of another, and 1 of the fourth. Now, if you were to fill this all in, you'd be able to figure out which one is which. I want you guys to know how to fill this out, but the ratios are also very important. Okay. If you guys look on your sheet on 57, this exact example is right there with this Punnett square. So you guys can fill it out, figure out, which one is which. My cat is screaming, I'm sorry. Willow, shut up. So, hopefully that helps. I'm going to go and make the next video.